So this is Raj. Hi, everybody. So for the next, I would say, 40 minutes or so, we're going to spend some time around this mobile journey that Carlos and I have been dreaming up. Actually, it's not just our dream, right? This is something that we've been working with our customers on for the last year and a half, 2 years or so. So some of this is our thinking from what we have seen our customers do. Some of this is thinking from what we've actually seen, how the adoption has occurred in the last 3-4 years. So the overall premise of this presentation is to hit the key highlights that we wanted to share in our thinking. Almost present an end-to-end view as you take your baby steps, whether it's a crawl, walk, run, or whatever analogy you want to use. And then eventually provide you with tips and tricks if you want to go down a path of building your own mobile app, whichever options you take, right? So for the next 10 minutes, I will spend some time setting some context, and then Carlos will actually walk us through an iteration of the flow, starting from a simple web app all the way building into the mobile app. So one of the first things I want to start off with is to set some context around who we're trying to target from this conversation, right? So there are several of you that are experienced app developers today that you might be building really cool web apps using all the latest, greatest frameworks. You might be using, language of your choice, whether that happens to be Clojure or Scala or Java for that matter, or .NET. But this presentation is focused on primarily for, like in our mind, the two key personas. One, I'm going to call Chuck. He's brand new to development. He has very limited web and app dev background, right? So maybe right out of college or maybe even a high school student dabbling in this, right? He's really curious about mobile and all the latest buzz. He actually uses several apps and would want to now get started on some of this, and that's where he is coming from. The second persona that we want to kind of highlight is Jen. She's new to mobile, but by no means is new to app dev, right? She's been building apps. She's probably been out of college for a few years, or less than a decade now. She's done maybe building backend apps, maybe even building web apps in the traditional sense, whether it's Drupal or PHP or Ruby on Rails or you name it, right? Her goal is a little different. She's not just curious about mobile, but she actually wants to build apps that are mobile ready and also want to take some of the power that Mike alluded to in his opening pitch. So the motivation of this talk came about because as we were talking to several customers, there was this great overload of information, plethora of information out there, but typically when we talk to either Chuck or Jane, that persona, they always had questions around how do I even just get started, right? There were all these frameworks. There are all these tools and technologies. Is there paid software, open source software, and whatnot? And do I start native first? Do I go? Several questions, which kind of led us to this next, epiphany that this is especially true for folks if Jen and Chuck come from typical enterprises where they've been maintaining or building or enhancing existing systems and haven't had a chance to get their hands wet in some of these newer technologies, right? So that's kind of the backdrop to who we are targeting, and so the rest of the talk will kind of anchor on Chuck and Jane. So when we started looking at this, of course, there's several great resources that are out there, right? So this is just a few bits that I picked up from O'Reilly's website. Lots of good stuff. I actually probably own 3/4 of these. I spend most of my money buying these type of books and reading ebooks and whatnot. Great stuff. But it all has a viewpoint in how they introduced app dev and mobile app dev, specializing in certain contexts, right? Whether it's domains that are on iOS or JavaScript primarily and so on and so forth. So what we wanted to do was take that and synthesize it. And so one of the things around this was to provide a single source for Chuck and Jane so they can start on the mobile journey and then evolve, right? So the approach that we're going to present is to make sure that they not only satisfy their immediate needs of whetting their curiosity, but also evolve to find and meet their user needs, whatever that happens to be. So a few concepts before we actually get into the code. In our simplistic mental model, right? When you look at this mobile space and how you want to get started from a programming paradigm standpoint, you have basically two orthogonal axes. At least that's how it exists today, right? It might change over time, So it's definitely a point of view that is true right now. So you can start natively based on the OS that your device supports, whether it's Objective-C or Java or C# or whatnot. Or you can go truly web first, where you're building everything web using web technologies and so on and so forth. There is a spectrum in the middle, which is where we are starting to see a lot of activity happen in the last 3-4 years. So I define the space on the left top corner as app containers. So things like IBM's Worklight or Accelerator or any of the mobile vendors that are out there that are building platforms to help with the application, starting from a mobile web standpoint or web standpoint. And then you have true native apps, so that people, which is how the mobile app industry started, right? People building native apps with Objective-C using Xcode on Mac and whatnot. So this is kind of the landscape today. And so what we wanted to do was kind of tease apart the things that are that the mobile disruption has caused, and how anybody can kind of leverage the best of what these two has to offer, right? So here's in a nutshell our premise of how to approach this mobile first approach, and the three things that should stand out. And again, the mobile disruption, like Mike mentioned, is nothing. It's nothing new anymore, right? Everybody's kind of lived through that. But things that we wanted to kind of tease apart, of course, everyone knows screen diversity. I'm sure some of you guys have heard of responsive design and so on and so forth. That's actually very subtle and can be huge depending upon what screen size you're talking about, right? So before, when we were doing it about a year ago, the screen sizes that I cared about was, of course, my phones, possibly some feature phones, possibly tablets, and of course the large screen TVs. So about 6 months ago, I changed that because I had to build an app for a car dash, right? So a dashboard in your car. So the screen diversity is going to continue to change, whether that happens to be your next automated teller that's going to have some form of mobile content that might be a different form factor, of course, processing power, so on and so forth. So we have to kind of have the technology choices and framework choices right up front to kind of help us not worry about some of this. The other piece, which is kind of subtle but very big, is the behavior changes, right? So before, when I was tethered to my desktop, the amount of times I check my email or the stock or my expense report submission is different now that I have the power in my phone, so I could do that when I'm waiting in Starbucks, for example, or when I'm working, when I'm traveling outside of my work. That brings in this notion of network independency, right? So we assume all of a sudden that everybody has a cell phone plan and is always connected. That is not always true, right? So, for example, my dad has an Android phone. That's great, so we can address the screen diversity and the behavior changes he went through, but does not take into account the low network that he has based on the region in India he lives in, right? So the network independency becomes extremely important, and not only for the typical use cases like my dad, but also cases where you have one of your employees works in a mine and needs to be offline for 2 days, right? So how does that actually work, and how does your app actually perform? So this, in essence, is all things we need to take into consideration when we're looking at mobile. And what we wanted to do was provide a path where you can start off at a point where that's it's still frictionless. So there's still some inertia that you need to overcome in terms of frameworks and tools and technologies. But once you get through that initial small hurdle, then you can start to evolve and grow, at least in our opinion, to anywhere on the spectrum that we have, right? So today, what we're going to show you is taking a path around building a simple web-based app, starting to include some patterns in, and we're going to talk about why those patterns are important, and then kind of evolve that into this hybrid container model where you can start to wrap this app using open source frameworks to create mobile apps. From that point on, right, so basically this is kind of the roadmap for today that Carlos will cover, so I'm going to skip through this. But what this leads us with, which I'll kind of wrap up towards the end, is once you get to a point of comfort, then you as a developer get to choose based on your user requirements, based on the constraints that you're faced with, and time you have to deliver, whether you want to go explore more of the web technologies, mixing in with native, or go more native, whether you want to mix in more native pages, include more native controls, so on and so forth. So at this point, I'm going to turn this over to Carlos, who's going to walk us through some of the demos. Carlos?
All right, thanks, Raj. So I'll start up with a slide on editors or IDEs. So this whole talk, you can pick which IDE you can use. You're not limited in terms of which IDE you can use to build an application. For example, if you were doing an Android application, you would be using Android Studio or Eclipse. If you were doing a Windows Phone application, you would be limited to Visual Studio and C#. If you were doing an iOS application, you would be limited to Xcode and Objective-C. In this case, you can use Vim, Emacs, Sublime Text, Brackets, and any of the other editors that are fully extensible. What I mean by extensible is that you can install things like autocompletion. They'll have syntax highlighting. You can add a linter. If you're not familiar with a linter, there are CSS linters and JavaScript linters, and they will warn you about common issues. For example, if you're programming in JavaScript, you need to worry about automatic semicolon injection. So these linters will warn you about those issues. So I'm going to briefly go over the technologies that I'm going to be using to demo this. Let's start with the server side. So we are going to be building a REST API using Node.js, in particular a third-party module for Node.js called Express. If you're not familiar with Node.js, it's a platform built on Google Chrome's V8 JavaScript engine, and it's used for building all sorts of networking applications. The goal here with Express is that we're going to be serving static assets, meaning HTML, CSS, and JavaScript from the web server, and we're also going to be creating an API. So we're going to have some endpoints that we're going to be contacting from our client application to access some information. In this case, our application is going to handle contacts, so we're going to have the following REST routes. You can do /API contacts, and you should be able to get all the contacts. You can do get/API contacts, passing in an ID, and you can get a specific contact. You can do a put on API/contacts with an ID, and it'll update a specific contact using the ID. You can do a post to API contacts, and it will add a new contact, and you can do a delete on API contacts to remove an existing contact. As for the backend, we're going to be persistent data on the server. So we're going to be using something called MongoDB, which is a NoSQL database. We're going to be using a third-party module for Node.js called Mongoose, which is going to give us schema validation. As for our data is going to be quite simple. It's going to have two key value pairs. One, it's going to be name, that's a string, and age, that's going to be a number. And then in addition to that, we have some metadata that Mongo is going to provide. For example, an underscore ID, which is going to be unique to a specific collection, and then _v, which is related to version for the database. The cool thing about using MongoDB is that unlike relational databases that typically won't be able to scale horizontally, as your application gets more popular, you'll be able to add more machines to be able to scale. In order to install modules, we're going to be using a tool called NPM, which is the Node Package Manager. In NPM, you can find all sorts of third-party modules. For example, there are modules for working with WebSockets, so if you need your application to work in real time, you can use that. There are various utility libraries, such as underscore and Lodash. There are libraries for testing, such as Mocha and Jasmine, and also plenty of tools, such as the popular build tool for JavaScript called Grunt. As for the server, if you don't wish to take this JavaScript approach, you can also use something like Ruby on Rails and Gems to get different packages and third-party modules and have a working API and serving static assets from that. We can also use Java Spring and Maven to do the same in a Java-based environment. As for the client side, we're going to start off with jQuery since that's what most developers are used to, and we're going to be using a package manager called Bower, which is similar to NPM, but it's for client-side libraries such as jQuery. That way we don't have to go into websites and figure out what the versions are. We're going to have some metadata as part of our application, and we'll be able to bring down the right version of our third-party libraries. Our application is going to look a bit like this. We have our Node.js application connecting to a MongoDB database for persistence, and then on the client side, we're going to be requesting, for example, the HTML for my app, and then the server is going to respond with that HTML, and we should be able to see our application. So I'll go and show a bit of the code here. So if you're not familiar with Node.js, the simplest example I can provide is the one they have on their main website, which is creating an HTTP server. So the first bit we do is we require the HTTP module. As soon as we have the HTTP module, we are able to create a server. And then in that function, we are going to be taking a request, which is what we get from the client, and a response, which is how we're going to be responding to the client. In this particular case, we're going to be writing an HTTP status code of 200 in the head, and we're going to set the content type as text plain, and we're going to be responding with the hello world text. We're going to be listening on port 1337 on localhost, and we're going to be printing a message that the server is running on that port. So if I go quickly to the terminal, and I run something like hello.js, node hello, I will get the URL, and I'll be able to go into any web browser and paste that, and we have our hello world from the server. The next bit is that we want to do more than that. We want to create our own REST service. So a simple way to do that is still using the same HTTP module, but we're going to be keeping a list of contacts in memory. So it's an array with name and age as the key value pairs. We create our HTTP server, and as soon as we get a request, we're going to check that it's from the URL API context, and the method is get. That way we're going to be writing JSON to the console, a stringified version of JSON to the console. And if we wanted to, we could implement all of the other API methods there. Same as before, we're going to be listening to the same port on localhost. If we switched over to the console, we can do node, and then the name of the source file, which is rest.js. And if we go into the browser and we do API contacts, we should be able to see our contacts showing up in the console, which is John Doe and Jane Doe. The next bit is that we're going to be including this third-party library that I mentioned called Express.js for our actual server. So here we have the package.json, and here we can list our dependencies for the application. So we have Express and Mongoose as our dependencies. If we see here in server.js, we're requiring Express. We're requiring a module that I made for the data layer. We're requiring some routes and the HTTP server. We create the Express application. Express is going to provide us with some middleware. So in this case, we're going to be parsing the body of post request of request to the server as JSON, and we're going to be serving static assets that are in the public directory. It also gives us a nice syntax for setting up the different routes. So here we have contacts, and then we're going to be pointing to the route to get all the contacts or get a single contact, update a contact, add a new contact, remove an existing contact. We're going to be listening on port 80, and we're going to be connecting to MongoDB on localhost. So if I go to the console here, I'm listening on port 80. I've connected to the MongoDB server. I have it here running as part of the console. And then I'm able to visit something like jQuery demo. So if we go here into the public folder, we can see that I have a folder called jQuery demo, which has an app.js file and an index.html file. It's quite simple. There's a title, jQuery app. We have a special meta tag for the viewport. So this is going to make sure that if people are looking at this in a mobile device, they won't be able to zoom in, and it'll look like you would expect on a mobile device instead of zoomed out. It's going to set the width to the device width and the height to the device height. If we go into the body, we can see that we have the contacts tag, and we have an unordered list with an ID of contact list, and then we have jQuery as our requirements, and then our application JavaScript code inside app.js. So if we go to app.js, we can see that we have a variable to keep the contacts in memory. We have a function that requests the contacts. Basically, we're doing a jQuery get on contacts, and as soon as we get those, we store them in the in-memory array, and then we're going to be rendering the contact list. As for the rendering part, we're going to be looking in the DOM for the unordered list with an ID of contact list. We're going to be getting the length of that. We're going to be emptying the list, looping over all the elements in the list, and then appending the current contact, which is the name of the contact in the array, to the list as an li element. So let's add a bit of functionality here. So we can go into the index, and we can add something like a input type with an ID of search field. And our goal here is to be able to filter contacts. So for example, when I write Carlos, I only want to see Carlos. So I can go into my app.js, and I can uncomment part of the rendering that takes care of filtering. So in this case, if I don't pass a filter, it's going to be undefined, and it'll just append the contact. Otherwise, I'm going to be checking if the contact is, if the filter is part of the current contact, then I'll append that. If I save and I refresh, I need to also enable a onKeyUp event on the search field in order for this to work. So every time I write on the search field, I am going to be getting the current value of the search field, and I'm going to be rendering the contact list using the name on the search field. So if I save and I refresh, I should be able to get my filtering working. Let's also go ahead and add more functionality here. So let's say that we want to have some fields and a button to add new contacts. We can simply have here input type for name, and an input for the age, and a button for adding new contacts. And it shows up right here in our application. If we move on to our application.js, we're going to have to do two things. One is specify the code that we're going to be using to contact the server. So I have this add contact function, which is going to do an AJAX call to the server, It's going to make sure that I send JSON and I expect to get JSON back, and I'm going to stringify all the data. When this is done, it's going to call the callback inside the done function, and it's going to push the contact from the response into the contact list. It's also going to re-render the contact list. Remember, as part of re-rendering, we are also emptying the list. And if it fails, we'll get a warning message. Again, we're going to need to listen to click events on the DOM. So in this particular case, in the input DOM element with an ID of add button. So we're going to uncomment that, and as I refresh, I should be able to add a new contact. So I can do hello, 12, add, and I have my contact there. So our application right now is mobile ready. What a lot of people do is they put it in a different subdomain. So for example, m.myapplication.com, and then it'll show that mobile ready application. If they're implementing something like responsive design, then they'll just have the same static assets and view that across all the different screen sizes and resolutions. But our application, it's going to need some structure. We don't want to be working directly with the DOM, directly with all these low-level APIs, such as doing AJAX calls directly. We want something that already understands REST, understands the architecture on the server, and can help us better design our application. So this is where this MV star model comes in. There are a lot of JavaScript frameworks out there that fall into this umbrella. The typical description for this is that you have a model, which is going to be storing some amount of data. You have a view, which is what the user is going to see. And you have a controller that's going to get data from the model and put it in the view. A good example of that is the AngularJS framework by Google. So we're going to have our same application, but we're also going to request AngularJS from the server, so we'll have it on the client, and we'll be able to have more of an MVC, model view controller type application. So if we switch over to the code, we can see under the public folder, there's an index.html file. And here we're basically we have a title of contacts. We're adding some CSS for the application using a third-party library called Twitter Bootstrap. I also have a meta tag with a viewport to make sure this looks nice on mobile. Inside the body of our application, we're going to specify that this is a AngularJS application named Contacts App. We're going to have a div with a class of container using the ngView directive. So that's the part of our application that's going to be changed as we're visiting different pages. We're going to have a couple of script tags at the bottom for AngularJS and a script tag for our application. So if we go and visit that application right now on a web browser, it's just going to output the contacts as text. Let's go and improve that. So the way an Angular application is structured is you can have various models which wrap different bits of functionality about your application. In this particular case, I have a module for my whole contacts application. There's something called a config function that you can call to, for example, handle routes in your application. So using dependency injection, we're going to be getting a route provider, and the route provider is going to specify that when we're at the root of our page, we're going to be requesting the main view, and we're going to load the main controller. When we're at /view with an ID, we want to view a specific context, so we're going to request the view.html and load the view controller, and similar for edit and add. Otherwise, we want to redirect to the main page. Angular has this concept of services. So services can either have some business logic, or they can be in charge of communicating with various backends. In our case, we're going to have a service which corresponds to context, and it's going to be in charge of communicating with our REST API and handling the different resources. So by dependency injection, we're going to be getting this Angular resource. We're going to be specifying the URL. So it's going to be API context and an ID. Since we're using Mongo on the server side, every time we pass an ID, it's going to automatically change to an underscore ID, so Mongo can understand it once the request reaches the server. And then we're going to explain the different methods that we support. So we support a query that is going to use a get, and it's going to expect an array back, which is going to return all our customer objects. We can have a get that is going to return a single customer with an ID, and similar for adding new customers, updating customers, removing customers, and removing customers. From our service, since this is pretty much a singleton, we're going to be returning an object. So here I have a get call, which is going to create a deferred and then return a promise as soon as we get a customer by ID. We're going to resolve that promise. Otherwise, we are going to log the error and reject the promise. And the same thing applies to get all, remove, update, and add. The first thing that we're going to be loading is this main controller, where we're going to be getting the scope from Angular, and we're going to be using the contact service we just created in order to communicate with the backend and get our contacts. So here we're going to modify data in the scope with the title. So I could change it here if I wanted to, add a few exclamation points, save, and then it will automatically change. Our contacts that we're getting from the server. And if we switch over to the views, we can see that this is loading the main view. Here, I'm outputting the context. So remember that the scope has this data object, and then .context is going to be what we got from the server. So if I add context and I output here in double square curly braces, we should be able to see this here. Let's add a bit of functionality here. So Angular has this awesome concept of directives, which are ways of teaching HTML new tricks. So before, when we were looking at the jQuery version of the app, we would have to implement all this functionality ourselves. In this case, if we want to have a UL, an unordered list with various list items corresponding to every of the contact names, we can simply use the ng repeat directive in the li. So it would repeat for every contact in context and output the name. We can get rid of this part here and refresh, and we should be able to see our list. Now, if we want to, for example, add a filter field and then be able to filter these contacts dynamically, we can do that too. First, we are going to add the input so we can filter. We're going to tie that input to an Angular model, which we're going to be calling search. If I save, we can see this in the DOM, but it's still not working. So Angular has this concept of filters. So we can just use a single pipe character, then the word filter, and then the name of the model in order to filter. So we can do ng repeat and then filter search. And when we write different parts of the contact's name, we should be able to get a filtered version. Going forward, we also want to, for example, have a link you can click to view a specific contact. So we can have an href, which is going to point to /view with an ID. If we remember when we were setting up the routes, when we get something that's view with an ID, we're going to load the view controller, and we're going to load the view.html template. So if we go here into views, we can go into view, and this is simply going to output the title, the name of the current contact, the age of the contact, and it's going to have a back button. If we go into our main HTML and we uncomment this view link, we'll see that we get the link in the HTML and we're able to view a specific contact. And then notice that the URL changed with the ID of the contact in the database. To go back, we can have similar functionality for edit. In order to modify the contact, it would go into the edit route. And here we're going to have fields in order to change, for example, the name and the age of every contact. Similar way, we can also add functionality to remove. So here we're going to be calling functions that are specific to the controller we're on. So we're going to be calling the remove function, passing in the contact ID. When I click remove hello, even if I refresh, that hello is going to be gone. If we looked at what function got called, we can switch over to app.js. We're in the main route, meaning that we're going to go into the main controller. If we scroll to the main controller, we can see that scope has a .fn, which happens to be an object that has a remove function. We're going to be calling our remove service and then re-rendering the contacts once we successfully contacted the server and removed the contact from the backend. So we have
Carlos?
Yes.
Yeah, there's a question. Will the code be available somewhere for download? So when
yes, I will push it to GitHub.
Yeah, after he's done, we'll wrap up with the pointers.
Okay, excellent.
So at this point, we have a well-structured web application that works in desktop browsers and mobile browsers. So the next logical step here would be to package this application as a mobile application. So we want to mobilize it. One way of doing this is to use a framework called Apache Cordova. This was previously called PhoneGap, but when Adobe acquired the company that created PhoneGap, Nitobi, they donated all of the PhoneGap source code to Apache, so now it's open source and everyone can download it and use it for their applications. Eventually, we want our application to look like this. We're still going to be serving an API, and we're still going to be serving the web assets from the server. But in addition to that, we're going to have a Cordova application that's already going to contain all of the static resources inside the device once it's installed, meaning that it won't require network connectivity to access. You will still require network connectivity to access the REST API for getting the contacts unless you do some caching. But for the HTML, CSS, and JavaScript files, those will be packaged as part of the application. So as for Cordova, the easiest way to create a Cordova application would be to download Cordova from NPM, the Node package manager. Once you install it, you can call the command create, and then you can pass it a current folder. You can also pass it the package name and the name of your application, and it will automatically create an application for you. Then you can add different platforms. In this case, doing Cordova platform add iOS will add the iOS version of the application. Doing Cordova build iOS will build that application for iOS. So in that build process, two things are going to happen. Common resources that are in the www folder are going to be moved over to a platform-specific version, and the application is going to be compiled in some way. So if it's an Android application, it'll use the Android SDK to compile an APK that you can run inside an Android device or emulator. If it's an iOS application, then it'll compile it using Xcode, and you'll be able to run that in a simulator or on a real iOS device, and similar things for Windows Phone and BlackBerry. For the Android version, we have the same process. We build, emulate, and then we're able to see our application. Before I go into plugins, I want to briefly show how this looks. So if I go into my desktop, I already have a contacts Cordova application here. So it's going to come with 4 folders: merges, platforms, plugins, and WW. The one we care about now is WW because that one is going to contain all our web assets. So if I open that using Sublime Text, we should be able to see the content. So what I did, I copied over my dependencies from Bower. So I have Angular and Bootstrap and jQuery. I also copied over the script tag for my application. So you can see here that I have the Angular module and the different routes. I made no changes to this. And then for styling, I've used the same styles from the browser, and for the views, I used the same views. So we have a view to edit contacts, and the main view to display all our contacts, and the filter input, and then a view.html file where you can view a specific contact. Inside our index.html, I have my same application here, nothing special. We have an ng app, which is contacts, and then we have our container with an ng view, and then the only thing that's different is this Cordova JS that is going to be in charge of adding this bridge between web-only APIs and the access to native APIs. As an example of accessing a native API, I am going to show how you can add some geolocation. So if you go to Cordova's API site, if you want to add geolocation, it's just as simple as calling Cordova plugin add, and then you specify the name of the plugin you want to add. It uses a registry, same as Node.js, and there are a bunch of plugins that are in charge of doing different things. So for example, you can listen to native events such as the battery is low, the user pressed volume up or volume down. You can get information from all sorts of different sensors like the accelerometer. You can get geolocation information and so forth. So eventually we want our application to display a bit of geolocation information, and I have it here running. I have this alert geolocation, and it's going to be using Cordova's API to access it. How this works pretty much is calling this navigator geolocation get current position, passing in a success callback and an error callback. In the success callback, we're going to get a position object, and the position object is going to have things like the latitude, longitude, altitude, accuracy, and so forth. And if we fail, we are going to throw an error message. There is a bit of a caveat. If you're using Cordova with AngularJS, it won't know the scope of the application, so you're going to be doing a bit of extra work to wrap all the Cordova functionality into different services that you can use from other parts of AngularJS, such as controllers. I have an example of that. So if we go to app.js, if I scroll to the very bottom, I added so if we go to app.js and we scroll to the very bottom, I can simply uncomment this bit here. And this is going to create a geolocation. It's subtype factory. So in Angular, you can do a provider, and a provider can either be called a factory or a service. They're quite similar. In this case, we're going to be waiting for the Cordova ready call, and once the Cordova ready call, we're going to be calling the navigator geolocation get current position, passing in all the same parameters you would expect, the on success, error, and options. And when that's done, we're going to be applying the result on the root scope. And then we have the Cordova ready here. So we need to listen for the device ready event in order to be able to use Cordova's API. So this is what this method here is going to be doing. As soon as Cordova ready fires, we're able to use all the APIs that it provides. As for the actual implementation, I added a button to the main controller that it's going to provide us with geolocation information. So using dependency injection, we need to add geolocation. And as soon as we have geolocation, we're able to call get current position and get the latitude, longitude, altitude, and so forth, as we're able to see in the example here. So if you're interested about learning more about developing applications in this way, starting from pure web and then moving to a packaged application, you would be interested in looking at Yeoman, which is a generator for scaffolding projects. There's one specific to Angular, which is the Yeoman Angular generator. You would want to probably use a build tool like grunt.js in order to minify and concatenate resources if you're serving them from a web server. You would want to use Karma as a test runner, either if you want to test running your application test on a headless browser like Phantom.js or on Google Chrome, Safari, and so forth. There's also Jasmine if you want to write unit tests, and there are 3 good CSS frameworks that will give you a whole bunch of styling for free. So there's Apache Topcode, Twitter Bootstrap, and Serve Foundation. I'll pass the mic over to Raj for some closing notes.
Thanks, Carlos. So I think we were almost going to be out of time. So quickly to wrap this up, right? So at this point, now I have had basic geolocation functionality added to my app. If I want to invoke camera or any one of the other device functionality, I could do that. I'm still within my so-called web app using JavaScript function to call them. But I also can start to explore from my old picture that I had, start to go more native. I can start to mix in native pages. I can start to delegate offline functionalities using whether the cache model that the web might present or SQLite, an actual database that might be on the device, so on and so forth. So for some of the next steps and what we plan on doing with this, we'll actually make an update to our blog and our tweet handles, right? So we'll get that updated, and we'll get that out to Yaz for the actual samples that Carlos showed in the 3 different basic projects folders, for lack of better words, as well as actually running screenshots, so you'll see how that looks. So from this point on, right, so you can explore that on your own with the links we provided. We do have a thinking around this within IBM. Like I said, that there are a couple of products that we have that kind of emphasizes this philosophy. And if you want to know more, here's some of the links that you can go after. So at this point, we can take a few questions.
Yeah, I would like to at least get a couple questions in here. One is, how scalable is the Angular node trifecta model? Say I have 100,000 users a day or 1 million users a day. How scalable is that model? Yeah,
so I think it depends on exactly what the application requirements are, but I'm going to kind of armchair quarterback this, right? So the one way to think about it is you need to worry about hosting and how scalable infrastructure you have to answer that question. So assuming you have cloud scale models where you have either your own data center or you've kind of offloaded to a hosted model, then the software itself, because Node is stateless, and Mongo can, again, in this example of the data that we have, it doesn't have the strong requirements around asset transactions and so on and so forth. We can scale pretty well, right? And so from an internet scale standpoint, highscalability.com has several kind of notes and talks around this that talk to it. InfoQ also has several threads on this as well. So if you want to follow up more on that specifically, you can reach out to me or Carlos. But I would suggest you start from there because there's already tons of resources in how customers are using that today.
Excellent. Well, I think that probably should do it on the questions, and the other ones are more syntactical in nature, and I think that they're easily found on the web, the answers. So I just wanted to point out that there are other ways to engage with IBM Mobile First. IBM does offer a true end-to-end mobile platform, and there are 3 easy ways to get engaged. Visit the Mobile First site on IBM.com. Second, you can go to IBM Developer Works, where you can download IBM Worklight and you can access some tutorials there. And thirdly, you can either join the conversation by looking for IBM Mobile First on Twitter and Facebook. And those are great ways to stay engaged with IBM's Mobile First.
Yeah, and if they have any questions or want to follow up, we have the links up there, and I think the PowerPoint will be made available as well, so they can reach out to me or Carlos.
Yep. Yasmina?
Alrighty, and with that, folks, we're going to say a very big thank you to Raj and Carlos today for presenting an outstanding webcast for us all and for sharing their knowledge and expertise. Thank you, gentlemen.
Thank you. That was awesome.
We'd also like to say a big thank you to IBM for sponsoring today's webcast, and a big thank you to all of you that attended our event today. We hope you've enjoyed it and benefited from it, and I'm seeing so many outstanding comments, Raj and Carlos, coming in from the audience that they really did enjoy it, and they're all saying thank you. So excellent event all the way around. Folks, this will conclude today's event. Goodbye, everybody.